Hello, sir.
Hello.
Good morning.
Good morning.
Could it be better?
You want?
Okay.
Because I had one student in Hong Kong, but he didn't attend today. He said tomorrow. Okay, how's your day going? Everything's good in China?
It could be not better.
I see. Okay, let me start work. Thank you for sending me your work.
Yeah, I think my work is too much. Too many work.
Sorry, what did you say?
I think unit 1 and unit 2 is too many work.
No, you did good. I'm gonna send you different questions.
Okay.
Yeah. Not now, when I'm preparing material. Okay. Let me start. Are you in hotel? Yeah. Now in hotel.
Me in hotel.
No.
Yeah.
Are you at home or hotel?
Pardon me?
You are in hotel now?
Yeah.
When you wanna go home?
After 2 weeks.
I see.
Mm-hmm.
Justin is with you?
No, we are different.
Oh, she's from Beijing.
Yeah.
Okay.
Yeah. Right.
Okay, here. Let me start chapter. We did chapter 4, okay?
Okay, no problem.
Go for chapter 5. Let me. Oh, this is all of this. I remember. Yeah. We're gonna go chapter 5. Yeah. Derivative, or maybe we can do one sketching and okay. Let me do one starting, and then we go to.
Okay.
For instance, I'm going to look at one good question, sketching on on page 208, okay? Because we didn't reach here. Sketching and curve graph of polynomial function. Sketching, yeah, sketching, yeah, sketching and an accurate graph of a polynomial function. Take note. Sketching an accurate graph of the polynomial function. Okay. Okay. We have a function here. For instance, fx is negative 2x cubed, negative 2x cubed, negative 2x2 plus 5x, yeah? Negative 3x cubed, negative 2x2 plus. Okay, now we want to graph this function. You have some idea from advanced function, but here we want to be more accurate, yeah? Okay. First of all, what we want to do, we have to find, first of all, we want to find f prime x, f second x, yeah? First derivative, yeah? We want to find first derivative and second derivative. What is first derivative? Negative 9x squared minus 4x plus 5. Yeah? Negative 9x squared. Okay, this is the first. And then if we go factor, say f prime x equals 0, then we're going to have 9x2 minus 4x plus 5, 0. Then we're going to have, here we're going to have, say, negative 9x2 plus 4x minus 5, 0. Then negative, here we're going to have 9x, like that, yeah? 9x minus 5x plus 1. Okay, plus 1, like this, equals 0, because 9x2, this is 9x minus 5x, 4x, yeah? 9x minus 5x, 4x, negative 5, 1, yeah, that's right. Okay, now, in here, either 9x minus 5, 0. 9x is 5, x is x is 5 over 9. Here, x plus 1, 0. X is negative 1. Okay, two solution. Okay, then all we want to find is okay. Okay, then this is one question. Yeah. Another, when you find, you know that when we find f negative 1, then we're gonna say what is f negative 1, and then what is f 5 over 6. Yeah, 5 over 9. 5 divided by 9, 0 0.5, then 0 0.55. That was 0 0.68 and 0 0.6. That 0.6. F negative 1. What is F negative 1? Negative 2. Negative 1. Minus 2. Negative 1 plus. This is 3, yeah? Negative 2. This is negative 1. This is 3. This is negative 2. This is negative 1. Then 3 minus 7, negative 4. Yeah? F negative 1 and negative 4. Okay, 1 point, negative 1, negative 4. This one. For 0 0.6, we get negative 3. 0 0.6 cube. Yeah. Negative 3. 0 0.6 cube minus 3. 0 0.6 square plus 5. 0 0.6. Yeah. 0.6 cube 3 times 3. Negative 0.64 minus here, point here, 0.6 squared times 3, 1.8, 0.08 plus 0.3, yeah, minus 0.648, 0.732. Make sense? Okay. These are the point. Okay. Then we're gonna have, keep in mind, we're gonna have 0.6 and 0.732. This one, go for second derivative. F second x, f second x derivative, negative 18x, negative 18x minus 4, and negative 18x, yeah, negative 18x minus 4, 0, and 18x, negative 18x, then negative 18x is 4, negative 18x is 4, and x is negative 4 over 18. 4 over 18, 4 divided by 18. 0.2, negative 2. Okay, that's what. Now,
Okay.
now what we're gonna do, we can go for, okay, even we can evaluate, yeah, even we can evaluate that my, did you write or take note? I'm looking at page 28. How we can evaluate like this. Okay, we can evaluate second derivative for x5 or 9 and for f for x negative 1. Evaluate, yeah? Second derivative. For example, here we have f second x is negative 18x minus 4. Yeah. Then for x negative 1, because one was x negative 1 and one was x5 and x 0.6. What is f negative 1? Negative 18. This is 18. 18 minus 4. 14. Well, 18 times 0.6 minus 4. Negative, oh no. 18 times plus 4. 14.8. So F. Then here is 14.8. 14.8. Make sense? Then we try to determine concave up and concave down. Okay, the root of, we have this one. X is what? Negative 2/9. Concave up, where? Let me write for you here. This is a good example. At least we do one good example. Gives us idea. Concave up, because we didn't talk about that. F second x greater than 0. Yeah. Concave down, F second x less than 0. Listen, concave up, F second x greater than 0. Concave down, F second x less than 0. So then we go to graph. Now here. Interval, yeah, interval. F second x, graph of fx, Now, x is less than negative 2/9. Yeah, and x equal negative 2/9. Then x greater than negative 2/9. Yeah, makes sense? Now,
Yeah.
then because you pass this course, you have the knowledge about it. But again, we try to recover your weakness, the point you didn't get it. Huh? Okay, and that's useful for sure. You
Okay.
will learn this course much better, and we will end in even Alan. Even in break time, if you want, you can continue. I have time, if you want.
Okay.
Yeah.
Okay.
Then you can finish earlier.
Mm-hmm.
Okay. Now we want to determine the sign of f second x here. Yeah. We want to determine the sign of f second. Okay, here. For x negative. Okay, negative 2/9. For example, for x negative 1. Because f second x was what? Negative 18x minus 1, yeah. Negative 18 is minus 4. What is f negative 1, for example? Because 2/9 is what? 2/9. Because here, 2 divided by 9. 2 divided by 9 is 0.22. Yeah. F negative 1 is less than. Okay, then you're gonna have a negative 18, negative 1 minus 4. 18 minus 4, 14. Yeah. Positive. In here, 0. In here, for example, F1, negative 18, 1 minus 4, negative 18 minus 4, then is less than 0. When we have something like this, concave up. In here, point of inflection, you know that, yeah, point of inflection. Point of inflection. In here, concave down. Concave down. Concave down. Make sense? Yeah. Now we try to graph this function. Okay. For the you know that for instance, you see all is for one class. Yeah. All is for one class. For fx, negative 3x cubed, negative 3x cubed minus 2x2 plus 5 plus 5x. Negative 3x cubed minus 2x2 plus 5x. Yeah, here, makes sense? Makes sense? Here,
Yeah.
what is f0? F0 is what? 0. Correct? F0 is 0. Then what is x-intercept? What is x-intercept? Because when you graph the function, you should know that x-intercept, y-intercept. X-intercept, y is 0, yeah? Then, let me write here for you. You see how much piece of information you want? Then y is 0, yeah? Y is 0. Y is 0. Then negative 3x3 minus 2x2 plus 5x is 0. After x, then you're gonna get what? Negative 3x2 minus 2x plus 5 is 0. Okay, then if you factor negative x, either you can say negative x, either you can say negative x, 3x2 plus 2x minus 5, 0. Yeah? Negative x, then negative x, 3x, 3x minus 1, x plus 5. That's right, 3x2 or 5 here. Yeah, 3x minus 5 here. Yeah, 3x plus 5. Say here, say 3x plus 5, 3x plus 5, x minus 1, 0. 3x plus 5 again. This is 3x2, this is negative 3x, and then 5x. Yeah, that's right. Then either x is 0, 3x plus 5, 0. X is negative 5 over 3, yeah. X is negative 5 over 3. X minus 1, 0, x is 1. Listen, x is 1, yeah. Then, okay, we know this point x-intercept, they are important for us now. And then keep in mind, at -2, we're not point of inflection. This is important. Point of inflection means what? Change of direction of the, positivity or negative. Yeah? Yeah, makes sense? Yeah.
Yeah, of course.
Now we go graph. First point of intersection, 0, 1, -5/3, -2, negative 2, -5/3. For example, this is here. Makes sense? Then, for instance, we're gonna have something like this. This is -2. Yeah. Because if we put all this information to have accurate, then it's gonna be how? And then do you remember at -1? Because we had max and -1 and then 5/9. Do you remember? -1 is here, yeah? At -1, what we had? The function. The value of function at -1 was what? -1. Do you remember? -3. And then at -1, we had 3 here, at -1, 3 here, 2 here, -5 here, -6, yeah? No, what is this? 4, -4, yeah. Then exactly, at this point is what? -4, -1, -4. That's what? This is point of minimum. At x0, point of intersection, okay? Because, and then it goes up like this. Another point was 0.22. Do you remember? For maximum, yeah? 1 point something like this, and then it comes down, yeah? For example, at 1 coming down, at 1. This, for example, 0.2, this 1. This is the curve, yeah? This is accurate. Why accurate? Why accurate? Why accurate? Accurate is what? First, 3 zeros. Yeah? Listen, x1 here, -5.1 here, 0 here. Make sense? You see this point? 0 here, 1
Yeah.
here,
Mm-hmm.
-5 here. And
Yeah.
this is 3 points, x-intercept, yeah? X-intercept. 2 points for max and mean. This point, max. Okay, this fx0, x-intercept, yeah? F prime 0, max and mean, yeah? F second x0, point of inflection, write it down. Point of inflection, yeah? Point of inflection. Yeah. Point of inflection. Make sense? Point of inflection. Yeah.
Yeah.
Point of inflection. Point of inflection. You see? We can use different properties of a function. For instance, what is my name? For instance, my name is Mike. Yeah, Mike.
Yeah.
For instance, now I am a teacher. I am teaching. Yeah. For example, after 5 hours, I do another job. After 3 hours, I do another business. No, you have a function, but you extract, yeah, different properties. You extract different properties. Max, mean, point of inflection, and then x-intercept. Make sense?
Yeah.
Okay, then we did one question, good question for this Take a 5 minutes break. Take a 5 minutes. Okay. Take a break.
Okay, no problem.
Take a break. Alan,
Yes, sir. I'm here.
which city in China are you now?
Which city is the Guangzhou?
Text your text me. Text the name of city to me. Gongju, yeah, Gongju.
Uh,
Gongju is
Guangzhou.
south.
I sent to you in WeChat.
Yes.
Yeah.
Okay. Now, you text me.
Mm-hmm.
Good. Now, because my friend is in China now, yeah. Because our school, this kind of Cambridge Academy, yeah,
Yeah.
has one Chinese owner. We are two.
Ah,
Me and one,
ah,
my business partner. She is in China now. She's in.
yeah,
She's going to Dubai,
okay.
Gwangju, yeah,
Mumbai.
Gwangju,
Yeah.
Gwangju, yeah, yeah. She is advertising for a school in China because this school is also her school.
Mm-hmm.
And then yeah, and then we talk together. Okay, let's go further. Alan, when you got the whole our school website, your friend.
What
Sorry,
is me?
sorry.
Pardon me, I don't hear you. What do you mean?
I don't know what do you say.
I say, what did you ask me?
Oh, I said introduce our school to your friend if you can.
Yeah.
Thank you. Okay, now we are going further. Now I'm gonna go chapter 5. Okay. For the chapter 5, it was okay. Is chapter 5. Chapter 5, okay. Chapter 5.
Okay.
Chapter 5. Chapter 5 is here. Derivative of exponential functions. Yeah. Derivatives, yeah. Derivatives. Derivatives, yeah. Derivatives of exponential functions. Yeah. Exponential functions. Derivative of exponential function. Y ex. Yeah, derivatives of exponential function y dx. Okay. We has okay. For example, how we can find this derivative? Okay. Makes sense. If you remember, what was the formula? What was the formula for derivative? F prime x. Yeah. Limit fx. H approaches 0. Yeah. Makes sense. Fx plus h minus fx. This is approaches 0. Now, E x plus h minus ex over h. Am I right? Am I right, Alan?
Yeah.
Because you use the definition. You have seen this material. H approaches 0. Yeah? Then we're gonna have lim. Then you can say ex times eh minus ex over h. Then if you factor then h approaches 0, then you can factor lim ex minus 1 over h approaches 0. Ex, yeah, EX. Now, what is this ratio? EH minus 1 over H approaches 0. Make sense? Now, this is, what is this ratio? Let me try, okay? I'm going to evaluate EH minus 1 over H if H is 0.01. You know, E is what? 2.78. Make sense? Napier, yeah? Then let me calculate. One second.
No problem.
You are so interested. You are so good. Honestly, I like your attitude. You are good. E to power.
Thank you. This much.
No, seriously, you are a good student. I'm so happy. Yeah. E to power, Alan, E to power, E to power. I like to have 100 students like you. E to power 0.01 is 1.01. Yeah, 1.0. Okay. Now put it here. 1.01 minus 1. Yeah. 1.01. 1.01 minus 1 over 0.01. This is 0.01 over 0.01. What is this? 1. Yeah. This ratio is equal to 1. Then as a result, okay, then as a result, f prime x, you see this, can you see the red line? Can you see the red line? As a result, f prime x is what? Ex. Here, we did it, right? This one. Yeah. Do you need, I explain to you again or you are good?
Okay.
You see, I want to find out the limit of y ex. Yeah, I want to find out the limit of y ex. F prime x is limit of fx plus h minus fx over h0. Yeah, h0. Then limit, then e to power x plus h minus ex over h. Then limit ex, I expanded, yeah? Ex minus ex over h. Then if I factor e to power x, e to power h minus 1 over h approaches 0, then, okay, then the whole fraction, and then we evaluate for h 0.01, then the whole fraction, e to power h minus 1 is over es is what? 1. Yeah? Then, then this fraction is 1. F prime x is ex. Yeah, f prime x is ex. Yeah? Then we find the derivative is what? Ex. Make sense? Because we were looking for this, yeah?
Yeah.
Okay, write it down. I did for you everything. I use different approach. Now, the derivative of this, right? It's clear. Now I want to find out. I'm gonna finish with you after 20 minutes. Again, tomorrow at 8:30 Toronto time. Okay, 8:30 Toronto time. Or maybe night. Which one is better for you?
H, I think.
Because I have one student in Hong Kong, and then after him, I'm gonna teach you.
But when the 10 a.m. I have the course.
What course?
Is the other school is the BOH.
Oh, I see. Okay.
Business.
Yeah, anytime you can text me. Text me your time, okay? And then I add,
Okay.
yeah, text me.
Okay.
But Alan, but if you can do every day is okay. But we can finish earlier. Can finish earlier.
Oh,
But
okay.
it's not 3 days per week. You don't.
Yeah.
No rush, yeah. No rush.
Yeah.
Okay.
Yeah.
Now I'm going to solve one example
Okay.
first. Fx is e3x.
Yeah.
Then yeah, fx is e3x. Then dfx over dx. dfx over dx is, yeah, de3x over dx. Then all, because you're going to have derivative of this 3e 3x, right? Yeah, 3e 3x. Make sense? Because you can say like
Mm-hmm.
that. Because yeah, that's what. But you can say e d over 3x is 1. That's okay. Yeah. Another things I want to tell you. For example, fx is, say, e2x2 plus 3x plus 1 and evaluate at x1. For x plus 3, 4x plus 3, e2x2 plus 3x plus 1, x1, f prime of 1, prime 4, 1 plus 2, 2, 1 plus 3, 1 plus, then 4 plus 3, 7, e, what is this? This is 2, yeah, 3, 5, 6, makes sense? 2, 3, 1, then 7, e, e is 1, e is here, yeah? No, hold on. E to power 7, e to power 6, yeah? 4, oh man. Seriously? Yeah, 3 to power 6 next one. Hold on. 3 to power 6. Yeah, e to power 6 times 7. Altogether becomes 28,282. 2824. 28, yeah? That's, okay, write it down. Right?
Yeah.
Then I'm gonna move further.
Okay.
I'm gonna do something. Yeah. fx, not fx. E to power gx, yeah? What is title?
Mm-hmm.
Title, let me give you title. Derivative of derivative of a derivative of a composite derivative of a composite function. Derivative of composite function. derivative of a composite function involving e to power x derivative, yeah. Derivative of a composite function involving ex, yeah. Listen, f
Yeah.
is one. Now, for example, fx is egx, yeah. This is another function, yeah. This is another function. Then f prime x is what? G prime x is gx. F prime x is G prime x. F prime x is G prime x is gx. F prime x is G prime x is gx. Yeah. Then, okay. Then, for instance, this function gx is for example, this function gx is e to power x2 minus x, yeah. E to power x2 minus x. G e to power x2 minus x. What is g prime x? G prime x is, what is this power? 2x minus 1. Listen, 2x minus 1, ex2 minus 1. Yeah, 2x minus 1, ex2 minus 1. Listen, this one. And then fx is another function. Fx is x2 ex. Then what is f prime x? What is the derivative of this guy? First is what? 2x ex. Yeah. 2x ex, yeah, 2x ex plus this function x2, derivative of this function, derivative of x is 1, yeah, derivative of x, and then ex, yeah. We're gonna get 2x ex plus x2 ex, and x2 plus 2x. So ex, then x2 plus 2x. Make sense?
Yeah.
I'm gonna do another one. Let me
Okay.
do one more and then we move further. That's enough. And then I look at, I give you some work, then we can wrap up the derivative of general function y bx. We did it. Oh, bx, I told you bx. I told you this one. Yeah, we do. Okay, let me solve another one and then maybe we continue another 10 minutes and then see what. Can I raise it?
No problem.
No.
Yeah, you can.
Then oh, these are very interesting question here. For instance, this function. Fx is fx is 3 ex. Fx is 3 ex2. Then what's f prime? 3 is 3, ex2. Derivative of ex2 equals ex2. 3 derivative of this 2x ex2. Make sense? First, okay, now we come 6x ex2. 6x ex2. Then f prime, for instance, negative 1. F prime negative 1. 6 is negative 1. Negative 1, 2. Negative 6 e. Yeah, negative 6 e. That's it. Anyway, we can continue. As an assignment, I'm gonna give you some assignment. 2 page. Let me write some questions. Okay, I'm gonna write some questions. I'm gonna write for you. Okay. For instance, do this assignment. Yeah, for example, do this one. I'm writing for you. Okay. You wanna take?
Okay, Houston.
Y is e to power 6 minus 7x plus x3. Y is e to power 2 root x plus 2x2. Right. We don't have in the book this question, okay? For instance, we have, this is A, this is B, this is C. Gx, for example, we have e t2 over 1 plus 3e 3t2. Then this is one question 1, question 2. Fx, if fx is, for instance, 1 over 4 e 4x plus e minus 4x, calculate f prime negative 1, prime 1. Then if, right, because you don't have in the book, I'm writing by myself, okay? B, fx is
Okay.
e negative 1 over t plus 1. Then calculate f prime negative 1. Then do this one, then question 14 from page 2233, question 14. 12, 13, 12, I mean, page 223, question 12, 12, 13, 14. That's enough for today. Okay, thank you. Let me stop here.
Okay.
Take care. Write everything and then we continue tomorrow. Okay.
Okay.
Thank you very much. Take care.
Bye.